In section 4.3, we're proving triangles congruent by side, side, side. That's what the SSS stands for. And this is going to be the first of a few shortcuts that we use to prove that triangles are congruent. As of right now, what we talked about yesterday is that two polygons are congruent if and only if their corresponding sides and angles are congruent. So yesterday we talked about how if we want to show two triangles are congruent, you need all three angles congruent, all three sides congruent that correspond. So in this case, these triangles would be congruent. All three angles that correspond are congruent. All three sides that correspond are congruent as well. But do you really think we need all of that information to prove the two triangles are congruent? Do we really need all three sides, all three angles? Well, actually, we even talked yesterday about how you only need two angles congruent, and that third set of angles is automatically congruent by third angles theorem. So we definitely only need three sides and two angles, not necessarily all three. But we don't even need all of that info. I think you could start out and say, obviously one thing congruent, just one pair of sides or one pair of angles is definitely not enough. What about if you had two congruent parts in two triangles? Would that be enough info? Let's say we had two sides congruent, and if you see, I have these red sides are definitely congruent and these blue sides are congruent. I just copy and pasted, but two sides isn't enough because you can change the angle in between, and obviously these triangles aren't congruent. What if I had two things congruent, but it's an angle and a side? And you notice the red angle is congruent and this green side, but if you make this this ray or this side longer, as I did here, you can change the size of that triangle. So two pieces of info, whether it's two sides or one angle, one side isn't enough. What about two angles? Because we talked about yesterday, by third angle conjecture, if two angles of a triangle are congruent to two angles in another, the third angles are also. And let's see here, I'm going to ungroup this. If I just take this triangle, I'm going to copy and paste this. Right now, yes, they're congruent and all the angles are congruent, but if I expand this triangle, if I grab this corner and make it larger or smaller, check it out, the angles are still the same size. However, obviously the triangles are not congruent because one's larger than the other. So having two angles congruent, which actually means three angles congruent, still not enough. Three angles, you could have different size triangles. These triangles are actually similar. We'll have a whole chapter on similarity, but they're not congruent. So we must need at least three pieces of info to prove that triangles are congruent. And there are a number of different cases where three pieces of info is enough to prove triangles congruent. I want to look at what are my options. Alright. Basically, this is every order of angles and sides that is possible. Three angles. Did that work? Actually, we just talked about three angles because two angles congruent means the third angles have to be by third angles theorem, except for these triangles might not be the same size. Okay, grabbing that corner, expanding it, or contracting it, making it larger or smaller. The angles are congruent, but the sides are not. So we can actually automatically cancel out angle, angle, angle. This one does not work. Today, we're focusing on side, side, side. If we know three sides are congruent to three sides of another triangle, the triangles actually do have to be congruent. We're going to see that in a moment. In the next few sections, we're going to talk about side, angle, side. Notice the angle is in between the two sides. So I have two sides congruent and the angle in between them. Here I have angle, side, angle. In this case, the side that's congruent needs to be in between the two pairs of congruent angles. Here I have side, angle, angle, meaning you have one side congruent and then two angles after it. And side, side, angle. There'd be two sides and an angle not between them, being congruent. So we're going to talk about all of these eventually. Today, focusing on side, side, side. Don't worry about those others just yet. Okay. So I'm testing side, side, side right now. If you know that three sides of a triangle are congruent to three sides of another, is that enough info to prove the triangles themselves are congruent? So I took a red, blue, and green side, or length, and I copy and pasted them here. And now I'm going to take these and create triangles with them. Let's say that on this triangle I'm going to use the red side as my focus side, and then I'm going to try to somehow match up these green and blue sides. And all I can do is rotate them. I can't change the actual size here. It looks like I'm going to have to maybe make this obtuse here. Oops. really I'm just trying to create this triangle, get my green and blue to all match up here. Okay, I'm getting closer. Come here, blue one. Alright, hopefully this is pretty accurate. Alright, I'm going to stop there. I know it's not 100% perfect, but I'm going to group these together, okay? This is a triangle that I could form using the red, green, and blue sides. This one, I'm going to try to make it different, but I still have these congruent sides, remember, because they're all the same length. The green, blue, and red I had just copied and pasted. So now I'll try to rotate all these and see if I can get them to match up here. Alright, probably a little more. Alright, let's see how close I am if these... Well, hey, that's pretty accurate. Again, I'm going to allow this to be off just the tiniest bit, but no matter what, these triangles should be the same. It looks like it's just rotated, so I'm going to see if these triangles themselves are congruent using the same sides. Well, look at that. Again, allowing for the slight error because I was creating this, it seems that these triangles are still congruent. So I took 3 sides and I tried to make 2 different triangles. They ended up being the same. I'm hoping that you would agree that this makes side, side, side a valid shortcut. And it is. Side, side, side congruence postulate says if 3 sides of one triangle, like here, are congruent to 3 sides of another triangle, like here, then the 2 triangles are congruent. I don't need all the sides and all the angles. I just need all 3 sides congruent. And I can say that these triangles are congruent. I could write a congruent statement and say that triangle ACB, I'm just naming this one any old way I want, is congruent to triangle. Be careful with naming. Remember, everything needs to correspond. If I do ACB, I did the 1 tick mark and 2 tick mark sides. So I need 1 tick mark, 2 tick mark here. So it would be TRS actually. Making sure they correspond. And side, side, side congruence postulate says if 3 sides of one triangle are congruent to 3 sides of another, these triangles are automatically congruent. Let's use that to write a paragraph proof here. I'm trying to prove that triangle ABC is congruent to triangle DCB. The naming seems correct. A to B was a 1 tick mark side. I go along this middle side. DCB, 1 tick mark side and middle side. Now if I'm writing a paragraph proof, I start with what's given. Notice they're giving me, because of the markings, that side AB and DC are congruent. Because of the markings, side AC and BD are congruent. Wait, so I have 2 sides congruent to 2 sides of the other. What about the third side? Well, the third side of both of these triangles happens to be side BC. And if it's in both triangles, it's obviously congruent to itself. What property says that something is congruent to itself is reflexive property. And I'm good to go by side, side, side. Okay, so I start out and I'll say we are given that. Alright, I was given that side AB is congruent to side DC. And I was also given one other. I was given that side AC is congruent to DB. Those were the 2 tick marks ones. I'll just say because they are marked in the diagram. Apparently I want the word because. Sorry. Because they are marked in the diagram. That's what I was given. Those 2 sides are congruent. Also, I'm going to list that last side. Remember, side BC is a shared side, so it is congruent to itself. BC is congruent to BC by what property? Anything is congruent to itself by reflexive property. Look in the mirror, see your own reflection, remember? And property of congruence, because we're saying 2 things. One thing is congruent to itself. And now, check it out. Here's my first pair of sides that are congruent, my second pair of sides that are congruent, and my last pair of sides was shared. So now I can say what I was trying to prove, that triangle ABC is congruent to triangle DCB by our new reason we learned today, which is side, side, side It's technically side, side, side congruence postulate, but I'm fine with you just writing SSS for side, side, side. Okay, so using this fact that 3 sides congruent in one triangle to 3 sides congruent of another proves that they're congruent to write a proof. Oh, another thing you have to do today is take a look at pictures and decide whether triangles are congruent using that side, side, side congruence postulate. Make sure you're also looking at the statement that it's written correctly. Okay. So in this case, is triangle PQR congruent to triangle STU? Okay, first of all, I notice that I do have 1 tick mark, 2 tick marks, 3 tick marks. All the sides are congruent. I'm tempted to just write side, side, side and say yes, of course, but check your congruence statement. Is it written correctly? They did PQR. PQR would go this way, so I went the 1 tick mark and 2 tick marks. I better do the same here. STU. ST, 1 tick mark, 2 tick marks. Okay. So yes, these triangles are congruent by side, side, side congruence postulate. 3 sides congruent in both triangles. Triangles are congruent themselves. All right, what about here? Is triangle ACB congruent to triangle CAD? Well, I see that these sides are both 7. They're congruent. They share side AC, except for you notice that these sides are not congruent. We would need all 3 sides congruent for this to work, so no, these triangles are not congruent. So I'm going to say no, not all sides are congruent. We need all 3 pairs of sides congruent for side, side, side to work. Alright, what about here? We have triangle QPT and triangle SRT. Are they congruent? And initially you might say, oh look, these sides are congruent, these sides are congruent, these sides are congruent. Yes, side, 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 no problem. But remember to check the congruence statement. Is it written correctly? Triangle QPT. Q to P to T. So they did the 2 tick mark side, 3 tick mark side. Triangle SRT. SRT. They did the 2 tick mark and 1 tick mark. These are not written in the correct order. So I'm going to say not a correct congruence statement. I mean, this would work by side, 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 except for it's not listed correctly. I guess the correct way, if they wanted to do triangle QPT, congruent to triangle, now QPT, 2 tick mark, 3 tick mark, I would have to do RST. And I'll say that is correct. And it would be by side, side, side. So make sure today that even if it looks like side, side, side works, make sure they write their congruence statement correctly, otherwise make that change. Alright, an application of using side, side, side congruency. Let's say you're building a gate, or like sort of a fence, on the outside of your house. So the opposite sides of a gate are the same length, meaning these would be congruent, these would be congruent. And how could you put a brace on the gate to be sure it keeps the same shape? Right now, I mean, if you think about it, this can technically change shape a little bit. All that has to happen is these go at a little bit of an angle. So this angles out this way, and this angles out this way. Well, the lengths could all be the same, you know, but it's not keeping that rectangular shape or staying at right angles. It'd sort of be a parallelogram thing going on. But there is a brace that you could put in that would help stabilize this. And think about side, side, side similarity. Can we get side, side, side to work? Because that is a, that's something that guarantees that triangles are congruent. Can we get a side, side, side situation here? Is there a brace I can put in that would create 2 triangles that would have to be congruent? And hopefully some of you are noticing if I put this diagonal brace in, now it's congruent to itself. I can put 3 tick marks here, and now we have triangles that have to be congruent, cannot change shape because of side, side, side. So this is a brace I'd want to add. So a diagonal brace would be kind of the solution here, because it creates triangles that are congruent by side, side, side. And actually, to help even more, put another diagonal brace, and now it's as sturdy as it can be. Alright, so using side, side, side as a congruent shortcut to proving that triangles are congruent.